All right, here we go. Chapter 3 mid-review. Test is tomorrow. Make sure you do your practice test tonight. I've already passed that out. Again, that's just for you. So 1, 2, and 3, you had to decide if it was symmetric with respect to which of these lines. We've already talked about each question is going to have one line that we didn't even talk about. You know that one's not the right answer. A, where it says y equals negative x plus 9, we did not mention that anytime during our class, so you know that's not the answer. To work these, what do we plug in originally for x equals 9y squared plus 3? A and B, okay? Plug in A for x and B for y. So we're trying to get A equals 9b squared plus 3. That is our goal, okay? You do need to have these memorized, the choices, okay? So when you're trying to do the x-axis, you plug in negative a and b. When you're trying to do the y-axis, or excuse me, the y equals x line, you switch them and plug in b for x and a for y. And when you're testing the x-axis, you plug in a for x and negative b for y, okay? And plug those in and see which one gives you a equals 9b squared plus 3. All right, the answer is D, and so I'm just going to show you why. D, you're plugging in A for X, so A equals, and you're plugging in negative B for Y. So when you plug in negative B for Y, the B is being squared, so negative B squared is positive B, so it just simplifies to 9B squared plus 3, and that is the same as that. So that's why that's your answer, okay? If you plug in negative A and B, that gives you negative A equals 9B squared plus 3, which is not the same. It's not that, okay? This one has a positive A, this one says negative A. And then obviously for C, if you switched them and said B equals 9A squared plus 3, that's obviously not the same, okay? Everybody good on number 1?
Yes, sir.
All right. You do the same thing on 2 and 3. Oops. So 2 and 3, we're going to slide it down. You're plugging in the same ones. Which one do I know is not right? B, we didn't talk about a y equals negative x plus 6 line, so you know it's not that one. Again, I want to write them down every time just so you can see. If it's y equals x, we plug in B and A. For the x-axis, A and negative B. And for the y-axis, negative A and positive B. So you can kind of do it in your head once you get the hang of it. All right. What's being squared here? The x, right? So if you remember, we're going to write this. This will be B equals 6a squared minus 3. So since the a is being squared, do I care if it's positive or negative? No, because as soon as I square it, it's going to become what? Positive. So which one would be my answer? It is D again, okay? Same letter answer, but different answer, okay? It's the y-axis, because now when I'm plugging in B for y and negative A for x squared, okay, minus 3, the negative A squared, that's terrible. Let me fix that. The negative A squared becomes positive, and you end up with B equals 6a squared minus 3, which is, again, that's what we wanted. Yes.
Yeah. I don't understand.
What you're trying to get, you always plug in A for x and B for y first, and that's what you're trying to get every time. So I take my y right here, I plug in B, I take my x, I plug in A, and that's what you're trying to get, okay? Everybody good? The last one of these, this type, number 3. I'll plug in what we want it to be. So A is x. So A equals 2b squared plus 3. B is y. Again, you know it's not which answer? For these, it won't be A. Impossible to be A. Okay? For the y-axis, again, you make A negative, or the x negative A, I should say, and you make the y B. For the y equals x line, you switch them, okay? And for the x axis, you do a negative b, okay? And again, you're just testing the symmetry, okay? Which line, if you flipped it over that line, would the graph look the same? Okay, that's basically what you're doing here. So what's being squared here? The b. So what do you think your answer is going to be? D, the x-axis again, just like the first one. If you plug it in, a equals 2 times negative b squared plus 3. That square makes it positive, and we get the same thing that we got when we plugged in a and b originally.
So
All
it
right.
wouldn't be C because then the letters would be back.
Correct. If you plugged in C, I'll just do it down here. If you plugged in C, you'll get b equals 2a squared plus 3. And
Alyssa Brown one more time.
yes, ma'am.
Thank you.
And that's not the same thing. A equals 2b squared plus 3 is not the same as b equals 2a squared plus 3. Okay? Everybody good on those? All right. Moving on. Number 4. 4 and 5, probably the easiest questions on the test. So be careful that you don't miss those. Okay? It says the graph below is a portion of a complete graph, so you only have a portion of it. You're completing it. It says sketch the complete graph assuming it is symmetric with respect to the x-axis. So all you're going to do is flip it over what? The x-axis. Now, it doesn't have to be exact, okay? If you are pretty close, you're going to get it right, okay? Done. That's it. All right? Now understand, this is an example of something I wouldn't take, okay? You can do better, okay? Or something like, all right, that's, at least try to make it look mirror image to what's above it, okay? Like I said.
Mine's literally gonna be.
So we just need to show that we understand like where it needs to be flipped over.
Correct.
Okay, it doesn't have to look.
It doesn't have to look exact, okay? You don't have to go through finding points.
Oh, I was making sure.
Just make sure. Now, I have had some people, they'll mess up and they'll they'll draw it like that or something. That's definitely wrong. Like, I can't even justify that any way being right.
Flipping over
Okay?
the eggs and then
But
flipping
right,
over.
because it's not. Okay? It's gotta mirror it. If you took the paper and flipped it over, what would it look like?
Yes, sir.
All right? Everybody good on 4?
Yes, sir.
5 is the same, except you're flipping it over the what? The y-axis. So 5, you get to make, yeah, I'm loving it, okay? Little McDonald's, free advertising here. Again, doesn't have to be exact, but it needs to be pretty close. Everybody good?
Yes, sir.
All right, 6 and 7 are quite possibly the second easiest two problems, okay? To be even, odd, or neither. So, even, remember we talked about this, you don't really have to know this on the test, but if it's an even function, it is symmetric to what? The y-axis, okay? If it is odd, it is symmetric to the origin, not a line at all. Odd means you can turn it half a turn, and it looks the same around the origin. Even, it's symmetric to the y-axis. Like I said, you don't actually have to know that for the test, but it's good to know, all right? To be even, all the exponents need to be what? Even. To be odd, all the exponents need to be odd. It's as easy as that. If you have some even and some odd, it's neither. So, on number 6, the first x has an exponent of 3. The second x, there's no exponent shown, but what is the exponent there? 1. So 3 and 1 are both what kind of numbers?
Odd.
Odd. So this is an odd function. That's as easy as it gets. Okay? 7, the first x has what for its exponent? 6. The second one is a 2. The third one doesn't have an x. When it doesn't have an x, what is your exponent? 0. So 6, 2, and 0 are all what kind of numbers?
Even.
Even. So it is even. Okay? Another option you can do, I don't know why you would need to do it this way, because that way is pretty easy. You can remember what they're symmetric to and graph them. Okay? If you graph that in your calculator and see, hey, if I turned it, if you flip your calculator upside down, it looks the same, you know it's symmetric to the origin. Okay?
We don't need to do it that way.
I don't think you do either, but I'm just saying it's an
We're
option.
intelligent
It's an
people.
option. If it's even, you flip it over the y-axis, it should look
So
the
wait,
same.
when is it
Okay? I'm sorry?
When is it neither? Whenever it has odd
When it has both.
Oh.
If you have even exponents and odd exponents, then it's neither. Okay? All right? Number 8, we are translating. Okay? Remember, inside translates left and right. Outside translates where? Up and down, vertically. So, where is the +1 in there?
It's in the absolute value.
Inside. So it's going to translate left and right. And remember, inside is always opposite. So it's saying +1, but that actually means it goes what?
Left.
Left 1. So left 1 would be C. Everybody good on that?
Yes, sir.
Awesome. Number 9. Where is the 1 this time?
Outside.
Outside. So now that means it goes where?
Up and down.
Up and down. Since it's a +1, it goes up 1, which is B. Everybody good on that?
Yes, sir.
Halfway done, almost, after this one. 10. We are multiplying stretches and shrinks. Where are we multiplying? Where is that 3 at?
Outside, so it's
Outside, so it's going to be up and down, which is called vertically. So that means it can't be C or B. It's got to be A or D, and you just got to figure out, okay, it's 3. Would that be a stretch or a shrink?
Stretch.
Stretch. 3 is bigger than 1, so it's a stretch. So it has to be A. Okay? Also remember, if it's inside on these, it's backwards. So if it's absolute value of 3x, that is now a horizontal shrink by 1/3. Okay? Horizontal shrink by 1/3 because you got to flip it because it's on the inside.
Yes, sir.
Everybody good?
Yes, sir.
All right. 11, you're basically doing the same thing you were doing on 8, 9, and 10, but rather than them asking you what happens to the graph, they give you the graph and you have to change the equation. Okay? So, first off, what family is this? Quadratic. So when you make your new one, make sure it's a quadratic. The graph, the parabola is being shifted how far?
Left 5.
Left 5. So I'm going to put what where?
You're going to put a +5 inside.
+5, x +5 in parentheses. Don't forget your square. Can't tell you how many people don't put the square. Okay?
So if it's absolute value in parentheses, do the opposite.
If it's anything in parentheses, you do the opposite. Not just absolute value. If it was a quadratic.
No, I know, but like, and that goes with absolute value too.
Yeah, that goes with every family that you do. Moves it left and right. Goes inside. You do the opposite. Okay? It doesn't matter if you're talking about quadratics, cubics, absolute values, rational equations, square root equations. It doesn't matter. Okay? What I'm trying to say is, say it was f of x equals the square root of x. Well, to move that left 5, inside there, I'm going to put x +5. If I wanted to move it up 5, I would put +5 on the outside. Okay? So it doesn't matter what family you're talking about, you do the same thing. All right? 12, I believe the family is an absolute value, right?
Yes, sir.
Okay? So, we do the same thing. It gets moved twice, though. It moves right how far?
5.
And then down
3.
3. So, moving the right part's going to go where?
Inside.
Inside, and we do the opposite. So, it's x -5. And then it also moved down 3. So, on the outside, we just put -3. Done. Okay? And again, we know it's an absolute value 2 ways. The graph is a V. And it literally says absolute value of x in the problem. All right? Very good? Moving on. 13, 14, and 15 were your graphs. I do not mind if you... I do not mind if you use your calculator to help you, but make sure you give me the tables, okay? quick little table, and then we'll graph it. What would be my first x on 13? 0. And we would get -1, and then we pick a point on either side. So 1 and -1 would give you 0 and 0. If you wanted to do a couple more points, you can. You don't have to. 2 squared minus 1 is 3. -2 squared minus 1 is also 3. And then you just start the graph. So we got 0, -1 would be here. 1, 0 is there. -1, 0 is there. 2, 1, 2, 3 would be there. And -2, 1, 2, 3 is there.
Are you gonna like count off if we don't start with the same one? Like I got all those.
I am not going to count off if you don't start with the same one, but you need to have the vertex.
Yeah, I have it. I just
Okay.
had it in a different order.
No, it doesn't matter to me what order you write your points. Okay? I always start off with it just because it makes it easier to get the other ones.
How do you
Okay.
find the vertex again?
It's what makes whatever family you're talking about. So this one we're talking about quadratics. It's what makes the quadratic part negative. I mean 0, excuse me. Okay?
Is that why you chose 0 for your?
That's why I chose 0 for my first one.
So it's
I
not
understand. I'm
like-
not trying to make the entire thing 0.
Okay.
I'm trying to make the whatever the family part 0. So for this one, this family is absolute value. I'm trying to make the absolute value part 0. So I'm going to plug in what
I did the
first?
same thing, Caitlin.
-1.
-1. Because -1 would make the absolute value 0. Here, what's making the square part 0? 0.
I got it.
You with me?
So
Okay.
when do you try and make the whole thing 0? When is
You
it?
don't ever, to get your first point, you don't ever.
Don't ever.
You're always trying to make the family part 0 because that's going to be like your starting, that's going to be your middle of your graph, okay? And if it's a quadratic and absolute value, it'll always be your vertex, all right? Now, since this is greater than, only greater than, it's a dashed parabola, okay? Don't forget about that, all right? You won't get the whole thing wrong if you accidentally put a solid line, but I will mark off a little bit, all right? Separate the good from the better, all right? Greater than, shade where? Up. So literally, I put my pencil on the vertex, and I go up, and I'm inside it, so I shade everything inside. If you go down and you're outside it, you would have shaded everything outside. Okay? 14. Make a little XY chart. Again, I don't mind if you get your table from your calculator, but you need to know how to do it on your own. What would make the absolute value 0 there? -1 would be, make it 0. 1 to the left, 1 to the right would be -2 and 0. Plug those in.
You get one for both.
You get 1 for both. If you want to do 2 more, you can. They're not necessary, but you can. -3 and 1.
I thought you told us we had to have 5.
Well,
The only one that you need 5 for
Let's
is
just-
the one that
is the
goes-
cubes.
Okay.
that's really the only one you have to have 5 for is if it's a cubic, okay? But it makes it better if you have 5. I'll just be honest.
How do you get the Y's?
Plug x into the equation, okay? And I kind of grin because I think we talked about that. I know we did. May not have been. Teaching 2 classes of the same. Sometimes I get y'all mixed up about what I told who. Wait, switch that. So you just always, every time you ask me how do you get the y, I'm going to tell you, you plug it in, you plug x in and see what it gives, okay? So when you plug in -2, you get 1. When you plug in 0, you get 1. When you plug in -3, -3 plus 1 is -2, but the absolute value is 2, right? And when you plug in 1, 1 plus 1 is 2, and the absolute value of that is also 2. So we got -1, 0, -2, 1 would be up there. 0, 1 is there. -3 is up 2. And 1 is up 2. And again, it's just greater than, so I'm going to shade, or excuse me, I'm going to draw a dotted dash line. It's greater than, so I shade up. I'm putting it inside the V, so I shade everything inside the V. Okay? Everybody good on 14? Last one, 15. I like 15 because we can basically use the same exact x's, okay? What's the only difference between 15 and 17? I mean 14. There's a negative in front, okay? So we're going to have -1, -2, 0, -3, and 1. And over here where we got 0, 1, 1, 2, 2, it's going to be the same thing, but they're all going to be negative. So we got 0, -1, -1, -2, -2.
Wait, why did you change the negative?
Because there's a what out front here? A negative. All right, so -1, 0 would be here. -2, -1, 0, -1, -3, -2, 1, -2. This time we get to draw a solid line, and we're going to shade up or down. It's less than, so we go where? Down. That puts us inside again. Okay? Done.
Oh crap, never mind, I didn't do that.
And I heard somebody mention it. What are we doing when it's negative? When you put a negative there, you are reflecting it, correct? Okay? So did we reflect it over the x-axis? Yes. We also move it left 1, right? Is our graph moved left 1? Yes. Translated left 1. Same thing on 14. 13, it was translated down 1. Okay? So you can always do that and make sure you're graphing it correctly. Everybody good on
Yes, sir.
13, 14, 15? Awesome.
Can you leave it up there?
I sure can.
Okay.
Good? Y'all just playing with me now.
Next.
I know.
What?
What?
On this?
Everybody good? All right, 16. I may have passed it. I passed it. How did I pass it? Where that? Here we go. 16 and 17. They are your absolute value inequalities. Okay? So I'll put 16 right here. I think I can fit it. Remember the little jingle, less than and greater than or. Okay? Number 16 is a greater than, so it's going to be an or. All right, and what are the two equations? X plus 3 is greater than 1, or x plus 3 is less than -1. Got to flip the inequality and change the sign. And then you work them both out. So -2, -2, x is greater than -1, or -3, -3, x is less than -4.
So you always flip the sign and then make the
Inequality backwards. Like, flip the inequality and change the sign.
-2.
Okay.
sign of the six.
Sorry, I messed up. Thank y'all.
Be better.
And that's gonna be on video, and everybody's gonna like be, making fun of me and
I
stuff.
gotta click off your video.
They will. They're like, this guy, he doesn't know what he's doing.
There's not really no
There we go. -2. I didn't mess up the second one, did I? Yay. Okay. I'm good for at least 1 or 2 mess ups of a class. So. 17. 17 is just a little different. 16, they gave it to us ready to rock and roll. 17, though, they put this -5 with your absolute value, and you don't need to write your 2 equations until you get your absolute value by itself. Okay? You got to get it by itself first. So the first thing we're going to do is add 5. Okay? And that'll be 2 minus 4x is less than 7. Now we make our 2 equations. Okay? Do not write 17 and put less than 2 and then put greater than -2. It won't work out. Okay? You got to get your absolute value first by itself. Everybody understand that? All right. Now we make our two equations. So 2 minus 4x is less than 7. Since it's less than, it's going to be a what? And 2 minus 4x is greater than negative 7. And you work them out. These are a little bit more work than 16, so negative 4x is less than 5. And you divide by negative 4. X is greater than negative 5/4. Notice I had to flip my inequality again. Why did I flip my inequality again?
Divided by a negative.
I divided both sides by a negative. Okay? Can't do that. All right. Over here, minus 2, minus 2. Negative 4x is greater than negative 9. Divide by negative 4. X again, flip it. Flip the inequality. Positive 9/4. Less than 9/4. And it is an and. However, if you're taking the ACT or anything, they're not going to put and. They're going to write it as one fluid inequality. Okay? So they always put the smaller number first. Negative 4 or negative 5/4, excuse me, is less than x, which is less than 9/4. That's how they're going to write the answer. Okay? And basically, what's that mean? X has to come between what?
Negative 5/4 and 9/4.
Very good.
Would
That's
you-
exactly right.
Would it be fine if we wrote it down?
I'll take either way, but just know that's the way that the boxed way is the way, the more mathematically correct way. You got me? Okay?
Alright, come on, Coach Line, let's go. We gotta beat our time.
Yes, ma'am.
3 minutes.
Oh, we got plenty of time. 18.
You have 3 minutes.
These are the ones we went over yesterday. So we're actually going to do them out of order. We're going to answer the second question first because we can, okay? And then we'll figure out what the inverse is. So if what family is the given function? It's a quadratic. Quadratics, when you graph them, make parabolas, right? And would a parabola pass the horizontal line test? No. So the inverse is, it's not. The inverse is not a function. Okay? All right? Not a function. Now, we have to find the inverse. So what do we do with x and y? Switch them. So we're going to say x equals y minus 8 squared plus 9. And then after we switch them, we solve that equation for y. Solve it for y. So subtract your 9 over. X minus 9 equals y minus 8 squared. How do we get rid of a square?
Square root.
Take the square root. What's the important thing to remember when you take a square root? What do I need to put out front?
Plus or minus.
Plus or minus. Don't lose points because you forgot to put the plus or minus. Okay? And then we add what? 8. Add 8 for your final. I'll just put 8 in the front there. That's your final step. That is your function, or the inverse of your function, I should say. So it will be 8 plus or minus the square root of x minus 9.
Coach 9.
Sir.
What I did was I grabbed the x, like the x minus 8 squared plus 9.
To see if it's a.
Yes, sir. And
That's
then
fine.
then to find the inverse, I just flopped the thing like we were doing. Is that not right?
That is not correct. You are not actually finding the inverse. You're finding the graph of the inverse. You're finding the table
Okay.
of the inverse. They're not wanting the table. They want the actual
want the
function. They want the equation for
Yes, sir.
the inverse. Is that making sense?
Yes, sir.
Okay. So 19. What kind of family? It's
Linear.
linear. What's the slope of our line?
5.
5. Positive 5, right? So that's just a line that's going up. Correct? Okay. And notice, I'm not like taking the time to draw. I just want to know kind of the general idea of what it looks like. Would that pass the vertical line test?
Yes.
I mean, excuse me. I said vertical. It does pass the vertical line test, but does it pass the horizontal line test?
Yes, sir.
Yes. So this one is a function. Okay. So function. And then let's figure out what the inverse would be. So this one is pretty quick, actually. switch x and y. So y equals, oops, I didn't switch them, did I? Try that again. X equals 5y plus 3. And it's just a two-step equation. Subtract 3, x minus y equals, or excuse me, x minus 3 equals 5y. And you divide by 5. Boom. There's your inverse. X minus 3 over 5. X minus 3 divided by 5. Last one. What's our family on 20? Quadratic. So we already established, is a quadratic's inverse going to be a function? No. So it's not a function. All right. And let's figure out what the inverse is. So inverse of f of x will equal, let's see here, switch x and y. X equals y minus 7 squared plus 5. Move the 5 over. X minus 5 equals y minus 7 squared. Take the square root of both sides. Don't forget your what?
Plus or minus.
Don't forget your plus or minus out front of your square root. And last but not least, move your 7 over. So 7 plus or minus the square root of x minus 5. Okay? Any questions?
No, sir.
Awesome. That will end it.
You're such a fan.